In this video, I'm going to discuss the mean value theorem of integration and the average value theorem, and then show you how to apply those on a couple problems so that you can work on your homework problems. Okay, so the mean value theorem basically states this. I have this picture here, and you have these in your notes. If you have a curve, so the curve right here is f of x. This is a curve right here, this curve right there, and you have it in between two intervals. What we've been doing is if you integrate that curve, f of x, if you integrate f of x, it gives you the area underneath the curve, which is the red area. I kind of tried to scribble in there. So the red area under this curve right here. What the mean value theorem says is that somewhere on that function there is a point C, okay, where when you there's a value C where x equals C, where f of C would give you the height of a rectangle that would have the same area as the area underneath this curve. So the mean value theorem says that let's say the area under this curve is 5, there is a point C in between A and B where the area of the rectangle formed by going through point C, this green area, would also be 5, okay? It's guaranteed, all right? As long as this is continuous. So what that means is mathematically is this is what the mean value theorem says. The red is like the red here on my curve okay, that's the area underneath f of x. That's the curve, okay? This, the green, is the area of that rectangle. So the area of the rectangle would be, the height would be f of c, basically this point on the function at c. Okay, that would be the height. And the width would be b minus a. That's the width right there. So the area of that rectangle, that's the area of the rectangle right there, and this is the area under the curve. Okay? So that's what the mean value theorem says. A little addition to that talks about the average value theorem. So let's take a look at this is the mean value theorem. I'm going to manipulate it a little bit, and I'm going to multiply both sides by 1 over b minus a. And when I do that, I'm going to switch this around. I'm going to get f of c equals 1 over b minus a times the integral f of x of dx. Okay, so what this represents here, f of c, what that is referred to is the average value of f. Is the average value of f. So like I said, f of c is called the average value of f of x. Okay, that's what this represents. And then you're going to do a few problems working with these two theorems. So you may get a problem that says find the value of c guaranteed by the mean value theorem for integrals for the function over the given integral. Okay, so in order to do this, you basically need to remember you need to actually find the area underneath this curve between 4 and 9. Okay, that's what, go back, because if we want to figure out what c is, okay, we need to know what this is. Okay, so let's figure that out first. So I'm going to take the integral between 4 and 9, so that goes right here, of this, okay, dx. We're going to figure this out, okay? So my first step would be I'm just going to actually rewrite this as x to the 1/2 power dx. And then when I integrate it, come down here, I have to add 2 over 2 to the numerator, and I get x to the 3/2. Okay, and then I divide that by 3/2, but instead I'm just going to multiply it by 2/3. So basically I've just integrated that. Once I integrate it, I'm going to put my straight line here and go from 9 to 4 like we usually do. Then, just like we did our definite integrals, we have to plug these numbers in. So 2/3 times 9 to the 3/2 power minus 2/3 times 4 to the 3/2 power. Okay, so when you do this, you take the square root of 9 is 3. 3 to the 3rd power is 27. So basically you do this math, okay, and you get 38 over 3. Okay, now according to the mean value theorem, go back again, previous, this, which I just figured out was 38 over 3, equals f of c times b minus a. So this 38 over 3 equals f of c, which that's what I'm trying to figure out, I don't know what f of c is, times 5. Okay, how do I know b, how do I know that it's 5? B minus a, 9 minus 4 is 5. Okay, so I multiply both sides by 5, I get f of c equals divide both sides by 5. So I get f of c equals 38 over 15, or multiply both sides by 1/5. Here, I'll do this so that nobody gets confused. Okay, so that's what f of c is. Okay, now if I want to figure out so I'm going to go back, f of c is 38 over 15. So if f of c is 38 over 15, and I want to figure out what x is, I would have to solve this equation. So to solve this equation, because basically this is f of c would be right here, equals this. So if I square both sides, I'm going to get x equals whatever 38 over 15 squared is. Oops. So, there we go. X is approximately equal to 6.41778. 6.41778. My starting to lag a little bit. Okay. So that's how you can do some of the problems in your book. Another way they might ask you a question about this stuff is to say, find the average value of the function over the given intervals, and all of the x for which the function equals its average value. So you're kind of doing exactly the same thing. They're just calling it something different. So we're going to do this example right here. And basically what we're doing to find the average value, if I go back to my first screen, this is the average value function. So the average value, which is f of c, equals 1 over b divided by a times this, okay, which is really what we just did in this last problem. Sorry, this is taking a few seconds. Okay, so let's, first of all, I'm just going to write this out. So I'm going to put the formula here. So I'm going to figure out what this times this of f of x dx. So we're going to calculate 1 over b minus a. So that's 1 minus 0. So that's basically 1, okay? Then we're going to integrate between 0 and 1, 4x cubed minus 3x squared dx, okay? So we're going to integrate this. So this is going to end up being x to the 4th, add 1 to the exponent and divide by 4, and those will cancel. This is going to end up being x to the 3rd. If you add 1, divide by 3, and we're going to go from 1 to 0, okay? So if I do 1 minus 1, okay, that's going to give me 0. And then I'm going to subtract off, when I plug in 0, that would be 0 minus 0, so I'm basically doing this. It's pretty easy. I'm going to get 0 again. So what I got the average value. The average value equals 0. Okay, so f of c equals 0. And if I want to figure out what x would be, I have to set f of c, this is f of c, equal to 0. So I'm going to do 0, change colors here, 0 equals 4x cubed minus 3x squared, and solve for x. So going back to some algebra 2, we're going to factor out an x squared and get 4x minus 3. Okay, so x can be two different things. X can be 0, or x can be 3/4. Okay, two different answers. So there's two places on this curve where the area is the same as the area of the rectangle that would be made by that is the same as the area under the curve. So these are the two different types of problems, which really they're done almost exactly the same way. They really are done exactly the same way, you might notice, but the question might be asked slightly different. So in your homework you have a few questions that ask about the average value and a few questions that ask about using the mean value theorem. So you can kind of follow this example to do each of the different types, but like I said, they're pretty much asking the same thing. So hopefully this helps.